Hello wonderful people, it's your boy Nick Asa. You're welcome to another video. In today's video, I'm going to take you through how you'll be able to read your borehole survey report and understand what it's actually communicating to you. And it wouldn't be like you're always that kind of person who is reading information and doesn't know what it's actually telling you. And this is also going to help you to at least understand and have a fair idea about what that report is really communicating to you. Either it is giving you a positive feedback or a negative feedback. Stay tuned. Before I proceed to reading our survey profile, I would like to share a few tips about your test results. Whenever you send your water for a test and the results that comes out, how you'll be able to read that report and understand. So when you take the report, you can see that we have parameters, and then we have the results, then we have the standards. Okay, so when you look at a parameter, for instance, if you are looking at salinity, then you look at the results you have on salinity and then you compare it to the standards Ghana wants. So you will see all this in the report. I will show a sample on the screen for you to understand what I'm trying to talk about. Okay, so the first thing I want us to talk about is the pH. Okay, so you will see the pH as a parameter, then see the results you have, and then look also at the standards. Okay, normally pH has to be 7. So if you fall in the ranges of 6.5, 6.6, 6.7, you're good. Now let's look at the TDS. What is TDS? Generally, TDS is the total dissolved solid in your water. So if you are having a TDS which is below 15, then it means your water lacks minerals. And don't forget, it is measured in parts per million. So on your TDS meter, you will see ppm. Okay, so if you have 50 to 250, it means your water is good for drinking, but it has to go through adequate treatment. If you have 250, if you have about 250 to 1000, then it means your water actually contains salt and contaminants, and this has to go through a stream treatment before it will be suitable for drinking. Now the correct ppm to determine if your water tastes good is 50 to 150. This is the ideal ppm to tell you that your water has a very good taste. So if you have this, you're good to go. Then it means that your water is very good for drinking. So salinity is actually the measure of sodium chloride present in your water, and it is measured in parts per 1000 ppt. So on your device you will see ppt and the figures follows like that. Okay, so seawater naturally contains 3.5% salt by weight. So that is to tell us, or that means that in every 1000 grams of water, 35 grams are typically salt. So if you are seeing salinity on your report with that figures, it is talking about the salt content present in your water. So do not be confused. Okay, so a clear indication that your water is good for drinking, is actually safe and good for drinking, is a ppm ranging from 50 to 150. So if you are lucky enough and you fall a little bit more than these figures, like 60, like 180, 160, like 70, 75, you're so good to go. Now let's zoom into the focus of today's video. Okay, how to read your borehole survey report and understand what it's communicating to you. But before I proceed, I would like to advise you, before you drill a borehole, it is ideal to conduct a survey, at least to have a fair idea of the underground condition before you drill a borehole. Do not drill a borehole on a predicted basis. Do not predict drilling a borehole. Conduct a survey in order for you to know the condition underground, whether the underground is holding water or it is rocky. So that is what we are going to discuss in today's video. Okay, so when we say underground water, what do you understand by underground water? It is actually the rain that falls into the soil, okay, and it drains down on the underground. So there is something called pores. So we have pores in soil and in some rocks, okay. Pores is like a channel through which liquid passes through. So this rainwater that drains in the soil, okay, passes through these pores in rocks and these pores in the soil and store itself at a vantage place, okay. So it is ideal to conduct a survey before you drill a borehole. So whenever you receive your survey report, your profile, you will come across words like anomalous zones, aquiferous medium, aquifer, and aquiclude. Okay, you will see high resistivity, you will see low resistivity. In today's video, we are going to look at all these things so that you will have a fair idea what these are trying to communicate to you. Okay, so first of all, let's look at the aquiferous media. Now, aquiferous zones are zones where soil and rock have pores, fractures, or cavities of various shapes and size, which some of which contains water while others do not. Okay, so the pores that are permeable and saturated with water are typically called the aquiferous media. Okay, so if you are seeing aquiferous medium in your report, that is what it means. In simple terms, these are zones that the rocks are not too hard and it is presumed to contain much water. And in your report like this one, it actually signifies the blue color and it implies a good aquifer. So if you're seeing a good aquifer on your report, it means zones that has more water storage on the underground. Okay, so if you are seeing anomalous zones or aquiclude also signifies the red color on your diagram. So if you receive your report and on the diagram you're seeing the red zones, those zones are aquiclude or anomalous zones, and it means that these zones has a very hard rock. Okay, and in these zones we are not expecting to get water. So that is why it is advisable to conduct a survey before you drill a borehole. Okay, so aquiclude or anomalous zones have a very hard rocks and it does not contain water, and these zones signifies the red color on your report diagram. So if you're seeing this, that is what it means. So a good aquifer signifies a low resistivity. So if you're seeing a low resistivity on your report, that means you have a zone that the rock is permeable and contains a lot of water. A high resistivity is the rock that do not have the ability to contain water. That is the hard rock zones. Okay, so that's all I have for today. If this video has been so helpful to you, don't wait, hit that like button, subscribe to this channel for more amazing content like this. If you have a comment, leave it down in the comment section. Share this video so others can also benefit from it. See you in another video.